square roots or radicals, because not all of our roots are going to be squared in this particular chapter. So if it's not specifically a square root, then we just call it a radical. So essentially, the little symbol that you see like that, where we put something under there, that's the radical sign. And then depending, remember yesterday we talked about what number they put here, depends on if it's a square root or a cube root or fifth root, etc., etc. And one thing that we want to be able to do is make sure that everybody knows how to simplify radicals before we get going too far into this chapter. So, as far as if we were given the square root of 49, we would all be able to tell us that the square root of 49 is what?
7.
It's 7. Because 7 times 7 equals 49. And a lot of times we'll say it's plus or minus 7. That's plus. The orange is just a little too mushy. Plus or minus 7. So that you could have negative 7 squared and get 49. Or you could have positive 7 squared and get 49. So it could be plus or minus 7. But what if you were given the square root of 200? How many people remember how to simplify the square root of 200? Is this a perfect root? Does anybody know? It's not a perfect root. What is a perfect root that goes into 200?
100.
100, 25. There's a couple of different ones to pick from. So what we're going to do if we are given a number like 200 is we're going to pick a root that goes into 200. You could pick 4 and it would work. You just have a few more steps. You could pick 25 and it will work. You will have a few more steps. But if you pick the biggest one, so maybe start with the biggest ones you can think of and go from there, it will save you time later on. So I would think to myself if I was doing this, some of the perfect numbers I know are 4, because that's 2 times 2, and 9, because that's 3 times 3, and 16, and 25. So think about what perfect roots you already know. So like 5 times 5 is 25. Oh, that's a good one. 25 will work. 4 would work. I could keep going on my list. I'd have 36 and 49. We keep going. 9 times 9 is 81. None of these numbers seem to be working. And then I get to 10 times 10 is 100. So pretend there's some in there, right? 8 and 9 are in there. When I get to 10 times 10, I'm thinking to myself, that one works, and it's not going to get much bigger than that. So I could say that 200 was the same thing as 2 times 100. And I would say, okay, well then that means I have the square root of 2 and the square root of 100. And they're multiplying because I knew it was 2 times 100. I don't know what the square root of 2 is off the top of my head. And they don't want you to do it with your calculator. It's not 1. Because 1 times 1 is still only 1. But I do know what the square root of 100 is because I just figured that out over here. What's the square root of 100 again? 10. So I would take the square root of this number that I know, 10, and I'd still have the square root of 2. So normally then, we would write this, so this comes down here and this comes down here, plus and minus 10 times the square root of 2. Plus and minus 10 times the square root of 2. Let's try one more. Let's try 125. The square root of 125. 125 as a cube root, that I was good with.
Yeah.
But as a square root, it's not going to be a perfect number. So I'm going to think about my list again over here. What one stands out to you as one we should try?
25.
25 stands out to me too. So I might have to get out my trusty dusty calculator and I might have to say, okay, 125 divided by 25 is how many? 5. Perfect. So I could say that this was the square root of 25, whoops, times the square root of 5, right? because 25 times 5 equals 125. What is the square root of 25?
5.
5. Do we know the square root of 5 itself?
No.
Nope, so we're going to leave that, the square root of 5, and I just want you to really get in the habit of writing that plus and minus out front.
You know, in my
Sometimes we'll only care about the plus one. There are going to be times when we want two answers, and the only way we're going to have two answers is if we have one answer that's a positive and one that's a negative.
I would also check that in my calculator. If I was really unsure of my math, I could say, well, the square root of 125 is approximately
Decimal, something
right,
decimal.
and then check to see if 5 times the square root of 5 was that same approximate decimal.
Right. And one thing to keep in mind is that when you're putting it in your calculator, and let's just do that for a second. So we have the square root of 125. The square root of 125 is like 11.180339989 something, something, something. Possibly. And depending on where your calculator rounds it off, you and I might not have exactly the same thing here. And if you round it off here, which we're going to try to start rounding off to 3 decimal places, and I round it off to here, or somewhere else, we might end up with a whole bunch of different stuff. Like one of us might have 11.2, one might have 11.18, and most of the time that doesn't matter. But there are going to be some occasions, especially in real world, that would matter. So, you know, maybe 11.2 is just fine if we're just guessing the size that we're going to weigh something to be, like a candy bar. If you give me, you know, a 10th extra, I'm not sad that I got a 10th extra of chocolate. But if my tire is a 10th too big for my car, it is not going to work so good. So, you know, there are times when it actually will matter where we round off and how close we are. If we leave it like this, it's an exact answer. We can't have any confusion about that at all, which is why a lot of times they'll just leave it like that.
Yep.
Questions about simplifying our radicals, because we're going to do something like that. We're good? All right. Then, continuing on with our exponents and roots, our notes from the book